Hello everyone. Today we're going to solve an elegant geometry problem involving two tangent circles and their diameters, and in the end we're going to find the ratio r over r. Here's the setup. We have a big circle with center O and radius r. Inside it there's a smaller circle with center P and radius r. The small circle is tangent internally to the big one. Two perpendicular diameters of the large circle are drawn, one horizontal and one vertical. Along the horizontal diameter, the small circle meets it again at a point M, and we're told that segment AM has length 16. Along the vertical diameter, there's another marked segment ND, and that length is 10. Before we begin calculating, pause for a moment. Look carefully at those two diameters. The horizontal one gives you a direct linear relationship. The vertical one hides a right triangle. Think about how those two pieces of information might connect. All right, let's continue. First, focus on the horizontal diameter. Because the small circle is tangent internally to the large circle, the distance between their centers is r minus r. That's a fundamental geometric fact. When one circle sits inside another and they touch, the centers are separated by exactly the difference of the radii. Now, look at segment AM. If you trace from A across the diameter to the small circle and out to M, that entire stretch represents twice the distance r minus r. In other words, AM equals 2 times r minus r. We're told AM equals 16. So we write 16 equals 2 times r minus r. Divide both sides by 2. R minus r equals 8. That's our first key relationship. Keep that in mind. Now let's turn to the vertical diameter. Point D is the bottom of the large circle. Point N is where that same vertical line meets the small circle. Because the small circle is shifted horizontally by r minus r, when we drop a vertical line through its center, we create a right triangle. The horizontal leg is r minus r, which we now know equals 8. The hypotenuse is r, the radius of the small circle. So the vertical distance from the center P down to N comes from the Pythagorean theorem. That vertical segment equals the square root of r squared minus 8 squared. Now, ND is the distance from the bottom of the large circle up to N. So ND equals r minus that square root. We're told ND equals 10. So we write 10 equals r minus the square root of r squared minus 64. Rearrange this. The square root of r squared minus 64 equals r minus 10. Now square both sides. R squared minus 64 equals r minus 10 squared. So far everything is clean. Now here's where we use the earlier result. We already know that r equals r minus 8. Substitute that into the equation. Expand. We're left with 4r equals 100. So r equals 25. Now substitute back. R equals r minus 8. So r equals 25 minus 8. That gives r equals 17. And finally, the ratio we were asked for, r over r equals 17 over 25. Notice how the entire solution depended on two geometric observations. The horizontal diameter gave us a simple linear equation involving r minus r, and the vertical diameter created a right triangle, which introduced a square root. All right. If this explanation helped you see the structure more clearly, go ahead and like the video. And if you enjoy geometry problems that blend visual reasoning with algebra, make sure to subscribe. Thanks for watching, and I'll see you in the next one.